Okay, so we have now taken a look at the list, tuple, and set collection types that are built into Python. A fourth collection type built into Python is this thing called a dict, or dictionary. We're going to take a look now at the definition and usage and interaction that we can do with dictionaries. And at the conclusion of this, I'm going to say a brief little bit about object-oriented programming. So a dictionary, a dict, is another mutable collection type, but each item in a dictionary consists of two values. There's a key value, a key value, and a value value. Okay, let's try that again. So each item consists of a key and a value. And a dictionary is defined between curly braces as we used curly braces for the set. For the keys have to be unique and hashable. So the restriction on keys is the same as the restriction on items that you can put into a set. It turns out that there's no restriction whatsoever on the values corresponding to the various keys. So the values can all be the same or different. Values can be mutable or non-mutable. Values can have different data types. You could have a value that's an int and another value that is a tuple of strings. Let's take a look at an example. Here I've got a variable that I'm calling n2e, which will stand for name to email. This thing is a dictionary. I define it using curly braces, and my first key is John. Then I have a colon followed by the value corresponding to the key John, which will be jkostland@gmail.com. Okay, so in other words, the key is my first name, and the value corresponding to that key in this case is my Gmail email address, and that is actually a valid email address. You're welcome to send me questions at any time at that address. So there's our first item in the dictionary, consisting of the key John and the value jkostland@gmail.com. The second item is going to be the key Al with the value al@alcorp.net. All right, now this is made up. I don't believe there's an alcorp.net. I hope not. And the third value that we're going to put into our dictionary is the key Bob with the corresponding value bob@basok.com. And that's it. So this dictionary, N to E, name to email, has three items in it. The first item has key John and value jkostland@gmail.com. The second item has key Al with corresponding value al@alcorp.net. And then the third item has key Bob and value bob@basok.com. And when I hit the other key, since I didn't get yelled at, I presume something good happened. If I type just plain N to E, by default the shell will display back to me a representation of that dictionary, and I can use the type function to confirm that N to E is a dictionary. So what is a dictionary? Well, think about a dictionary of a human language. In an English dictionary, you look up a word. That's the key that you use to look in the dictionary. And then the value associated with that word is the definition and perhaps some examples of how to use that word. In Python 3.7, and this, by the way, is not true of older versions of Python, the items are guaranteed to be stored in the order of key creation. All right, so unlike a set where the order of the items is undefined, in this dictionary that I just created, since John was my first key and Al was my second key and Bob was my third key, those items are going to be stored in the dictionary in that order: John, Al, Bob. Just as I can look up a word in an English dictionary and find its definition and some examples, I can use my N-to-E dictionary, name to email dictionary, and give a name, one of the keys, and get back the value corresponding to that key. All right, so there is John's email. Here is Al's email. If I try to look up a key that doesn't exist, I get a key error. I get yelled at and told, well, that key does not exist in the dictionary. Turns out to be very easy to add new items to the dictionary, because you can simply say the name of the dictionary and in parentheses give the new key for the new item that you want to add, and then use assignment to specify the value for that key. So I'm adding a fourth key, psi, and psi is at nouniversity.edu, N-O-U.edu. Okay. So since psi was the fourth key created, it's guaranteed that psi is going to be the fourth item in the dictionary. I can also look up a value corresponding to a key and then change that value by assigning a different value. So here I'm saying N-to-E sub John gets J. Ostlund at andrew.cmu.edu. And again, that worked. And what will happen is the key John is still going to be in the dictionary. Because John was the first key created for the dictionary, it will still be in the first position. It will still be the first item in the dictionary. But the value corresponding to John, that is John's email address, will have been updated to jostlund at andrew.cmu.edu, okay, which is also valid. So either of those two email addresses will actually work for me. There are several named operations that you can use with dictionaries. We saw that if I look up a non-existent key, I get yelled at. As an alternative to using the square bracket notation to look up the value associated with the key, I can say N-to-E dot get and a key. If I do this, I don't get yelled at. But what happens is that none gets returned to tell me that there was no value corresponding to Ellie. Notice the difference here. If I say N-to-E dot get Bob, then I get the value corresponding to the key Bob. But if I say N-to-E dot get Fran, there is no key Fran, so I get none back. Now you may recall once upon a time I said that none is not displayed by the shell by default. If you want to see none on the screen, you have to print it. All right, so let me do this. Let me say eval, that's a keyword, em gets N-to-E dot get Bob. All right, so EM is email, and what I have EM referring to now is the value associated with the key Bob, if there is any such value. And when I print EM, I see that the value associated with the key Bob is Bob at BSO. But if I say EM gets into E.get Ellie, well, there is no key Ellie in there. If I print EM, I see that EM is referring to none. Okay, so that means that there was no value corresponding to that key Ellie. Bottom line is that get is a way of obtaining the value associated with a key, even if the key might not exist, without getting a, whoops, didn't mean to change the size of my window, without getting an exception. Okay? Pop item will return an item from the dictionary. Let me display the entire dictionary to remind ourselves what's in there. Okay, so I've got 4 items in there now. John with John's email, Al with Al's email, Bob with Bob's email, Cy with Cy's email. If I say ente.pop item, the item gets returned to me as a tuple. Tuple meaning it's stored in parentheses. The key is the first value in the tuple. The value corresponding to the key is the second value in the tuple. And it's going to be the last item. This is in Python 3.7. I get the last item from the dictionary. All right, so that item is now gone from the dictionary. And if I do end-to-e.pop item again, this time I'm going to get Bob. Prior to Python 3.7, older versions of Python, Python 3.x, did not give you any guarantee about what pop item would return. So in Python 3.7, it is guaranteed that the value you get back from pop item is the last value that you had added. Now let me put these guys back so that I don't have just 2 items in my dictionary. So we're going to say end-to-e sub Bob gets Bob Biasoak and end-to-e sub Cy gets Cy at no university. And now I'm back to having end-to-e with these 4 items in it. All right. Now I can also pop a specific item by specifying the key that I want to get rid of. And this will not only pull out the item and return, whoops, too much highlighting. All right, so pop will not only pull out the item and return the item as a tuple, but you can specify which key you want to pull out. Finally, another named method is clear, which will empty the entire dictionary. Here we have some illustrations of these various methods. Now, the dict, of course, is more complicated than the list, tuple, or set, because items in a list, tuple, or set are just individual items, and you can use the collection name itself, or the variable for the collection name, as an iterable. For a dictionary, you have your choice of 3 different iterables if you want to loop through what the dictionary contains. There is the keys iterable, which allows you to iterate over the keys. And then, surprise, surprise, there's the values iterable that lets you iterate over the values. The items iterable allows you to iterate over these tuples of key value pairs. So let's see what I'm talking about here, some examples. If I say for k in, and of course the variable name doesn't matter, I could just well said ASDF, but let me say for k in n to e dot keys, let's print the current key, and then let's print all of these on the same line separated by spaces. So I'm going to set my end keyword argument to space. And there we are. So I've iterated through the keys in the dictionary, and I get John, Al, Bob, Cy, and it's guaranteed that those will be in the order in which the keys were created. The values, on the other hand, I can loop through or iterate through by saying n to e dot values. These also are going to come out in key order, that is, in the order in which the keys were created, but this time I'll get values instead of keys. Once again, I want to separate them with spaces, and there we are. So I have John's email, Al's email, Bob's email, and Cy's email. If I loop through items, or if I iterate through items for I in n to e dot items, then each item in the dictionary is going to come back to me as a tuple in which the first item in the tuple is the key and the second item in the tuple is the value corresponding to that key. These are going to look pretty ugly if I try to display them all on a single line. So this time, let me just print each item, I, on a line by itself. And here we go. So the first item is John with John's email address as the second. All right, so we've got kind of recursive items going on here. So this whole thing here that I've highlighted is a tuple representing the first item of the dictionary. Within that tuple, the first item within that tuple is the key. The second item within that tuple is the value corresponding to that key. And I end up getting 4 of these tuples displayed. Let me do something a little fancier, just for illustration purposes. I'll say n to e dot items, and then let me say print name I sub 0. Okay, I is a tuple. I can access the initial item within that tuple by saying I sub 0. And then I'll say a tab and value I sub 1. All right, I'm not 100% sure that this is going to look good, but I hope it will. Yeah, good. So we got, okay, so because all of the names are shorter than 8 characters, this came out looking pretty nice. So we got name colon, and then we got a space because of this comma. All right, so that gave us name colon followed by space. Then we got the initial item from the current item I, the initial item from the current tuple I, which is John. Okay. Now, we used a tab, so that means, let's see, we've got 5, 6, 7, 8. So here's the first 8 characters. So that means that following this HN should be 6 characters worth for the tab. Actually, I kind of made a mistake because there's a space here following the name, and then there's going to be 5 characters for the tab. that should be a 5-character wide tab. And then value colon and space, and then the email address corresponding to John. Alrighty. It turns out you can iterate through the dict itself, but this won't give you the items in the dictionary. What it will give you by default is the keys. So I can say for val in n to e print val, and I will discover that I get the keys. Now I can use those keys on the dictionary to get the values, so I can say something like this for well, I mean, now that I know that it's the keys, I mean, I knew that it was the keys, but I was demonstrating for you that it's the keys. So now let me say for k in n to e, and let's print key k. Let me leave out my... No, I need to... okay, I'll put in a space here. And then let's say tab value. And to E... Whoop, whoop, whoop. Whoop. Okay, now up here I use single quotes around my strings. Down here I fell back into my habit of C++ programming and used double quotes, but it doesn't matter. They're, you know, I can use either single quotes or double quotes. I just have to be consistent. So I've got my double quote now, and then we'll say n to e sub k. That will be my value. There we go. So that's another way of looping through the keys and using those keys to access the value of each key. Alrighty. Now, we do have one potential ambiguity that we need to address now that we've introduced dictionaries as well as sets. Because we saw when we created a set that we used curly braces to create a set, and we've seen that when we created a dict, let's say n to n to age, name to age, okay, that's a huge lie, but whatever. I have a friend named Bob, so I won't lie about him. And so forth. It's easy for the Python environment to tell the difference between a set of values versus a dictionary of key value pairs because of the colon in here. But what about an empty set versus an empty dictionary? If I just type empty curly braces, what does that mean? Well, it turns out that that is how you write an empty dictionary. So here's my dictionary that's empty, DE for dictionary empty, and I'll just say open and close curly braces. The type of DE is in fact dictionary, and when I ask to see the representation of DE, I just get these empty curly braces. An empty set, on the other hand, has to be defined by using the set conversion function, which we'll look at in the next section, actually. That is an empty set. Its type is set. And to see that it's empty, to prove that it's empty, I don't know if this is proof, but we'll count the number of items in the set. And we'll count the number of Well, let's see now. If I give DE as an iterable, DE is a dictionary, what I'm counting here actually technically is the number of keys. But the number of keys in a dictionary is the same as the number of items in a dictionary, and this is 0. All right? So if you use empty curly braces, what you're doing is you're defining an empty dictionary, whereas if you use the type name set with parentheses after it, what you're doing is defining an empty set of items. Creating a set of one item versus a dictionary of one item is straightforward. Again, the environment, the Python interpreter has no trouble telling the difference because of the colon. All right, so if you use the colon, then that's clearly a dictionary, whereas if you use no colon, that's clearly a set. All right, so D1 is a dictionary, S1 is a set. Well, so we've now introduced the 4 built-in collection types in Python 3.7. We've got, and older versions of Python 3 as well. We've got lists, tuples, sets, and dictionaries. And the more experience you gain with these, the more power and flexibility you'll discover that you have for storing and manipulating and analyzing data of various kinds. The list, here we're saying just a tiny little bit about object-oriented programming. We are not going to try in this course to get into the details of defining our own classes, but the list and the set and the dict and the tuple are examples of built-in so-called classes. That is, they are data types that exist above the level of the low-level types, int, float, str, and bool. What they do is to provide an interface that you can interact with, and this interface is going to be some combination of operator symbols like get and less than and plus and star, as well as named methods like insert, append, pop, add, delete, etc. In addition to defining this interface of operator symbols and functions, the other thing the class does is to specify how the internal state of a given object of that class has to be maintained. All right, and the state for a list is simply a sequence of individual values. So, a user-defined class has to do the same thing. It has to define an interface that you can use for communicating with variables that you create that are of that class, as we say, and you have to describe how to store the internal state information for these classes. The purpose of object-oriented programming, one important purpose anyway, is instead of starting with your problem and pushing that problem down and down and down, closer and closer to the machine, where it becomes, more and more abstract in a way, we want to go the other direction. We want to take the language and pull the language up to the level that we're thinking about. So you might have a class of patients in a doctor's office, or you might have a class of stocks that you can invest in, or you might have a class of customers for a big retail operation, or a class of employees if you're developing a human resources application. And the idea of classes is so that you can write your primary program logic in terms of stocks and customers and employees rather than floats and ints and strs and bools. Okay, and so here are, several examples like person, employee, manager, savings account, etc., etc. Getting this all to work, now I get to use this horrible phrase, is beyond the scope of our course. It just requires too much picky, advanced syntactical knowledge that we simply don't have time to cover in a 7-week course. If you continue on after this course, future courses that you take very likely will talk about how to define classes of your own. You can also use classes, not only the built-in classes, list, tuple, set, and dictionary, but there are many modules that you can import that will define classes for you that you can use, like n-dimensional arrays from the NumPy module, and on and on. And we are going to make use of some of these classes that we pull in from predefined from externally defined modules that we can import into our own code. All right, so that's a hasty and not complete at all brush over object-oriented programming. The main thing that we did in this section, and the lab will give you some practice with this, is creating and interacting with dictionaries, or dicts, in Python terminology. Okie doke, so that gets us to the conclusion of week 3.